Hey, I'm Jake. Just wanted to introduce myself to you guys for Computer Science 111. Give you a little background on myself, as well as kind of what the course is going to cover, and a little bit about an introduction to computer science as a whole, what it really means, what it really covers, some things like that in case you're new to the program or if this is your first course within the program, anything like that. So first, a little background on me. I'm Jake. Call me Jake. If you need to email me, it's jmlake. Yes, my name is Jake Lake. jmlake@lcsc.edu. I work pretty much around the clock, so if you need help, shoot me an email. I'll get it. Try to get back to you. I'm on a different time zone than you guys are for the most part. I assume most of you are Pacific time. I am in the Central time zone. As you can see behind me, this is my hilarious office. You may see a cat hop into a video from time to time. So what do I do personally? I work telecommute for different clients doing web development. I'm a web developer by trade. Have a computer science degree from LCSC, and then I went on and did my master's at the University of DePaul in e-commerce, which is computer science mixed with marketing and business and web and all that stuff. So I used to be out in Lewiston. After I finished there, I worked at Schweitzer Engineering up in Pullman, and also taught courses there on campus, including this course. So I have a lot of background in this course, and kind of in CS in general. So in terms of what I do for clients, make a lot of websites. I like to work on just crazy idea things too, with friends or whoever. I like big ideas and I like to work on them, so I might show you guys some things during the semester. Oftentimes we find challenges, and I don't mean like coding is hard. I mean like people write assignments or coding challenges specifically to see, you know, can you solve this, or can you think in a certain way, something like that. So I like to work those into the course. They're fun little breaks from, you know, the drudge of what a lot of assignments might become, because they're very kind of done with a purpose in mind. Once we kind of get built up, we can start to branch out a little bit. So a little on education. So I used to teach this course on campus, as I said, and you know, I think a lot of people in the course that I've had previously are freshmen, or maybe they're just coming back, you know, after having done something else, and they might have a skewed view on education. So there's two quotes I always like to use in terms of education. One's by John Piaget. It says, "The principal goal of education is to create men who are capable of doing new things, not simply of repeating what other generations have done. Men who are creative, inventive, and discoverers." Women included in that. And then there's another one here by Bill Beatty, and it says, "The aim of education should be to teach us rather how to think than what to think, rather to improve our minds so as to enable us to think for ourselves than to load the memory with thoughts of other men." The reason I like to talk about this a little bit is that in this course, probably more than in any course you're going to see in college, maybe discrete math or something like that, but there is no formula given to you for how to do things. You have to invent it. If you've ever taken a speech course and you had to write an instructional speech on how to do something, you had to think, you know, how do I bake a cake or something like that. You have to pull the steps out of your own head. I mean, you can go and find someone else who's written how to do it, but for the most part, if you want to make something, if you want to invent something, if it's a cake that you want at the end of the day, you have to know and be able to communicate how to make that thing. And that is very much what this course is all about. It's all about logical thinking, about how to problem solve and how to repetitively problem solve. Um, if I tell you that 1 plus 1 is 2, you know that, but can you write the steps that make that a repeatable thing? It's kind of what we try and learn in this class. Is a little different way of thinking. It's not, hey, write me a paper and elaborate on blah, 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 where kind of anything works. It's very specific, and there's not a real guideline in terms of, the way that some things in math are done or something like that. I always think back to geometry, and when you have proofs, and there's a couple things that you can use to make that proof true. I call it a toolbox. That's kind of more what this class is geared like. I'm going to give you a toolbox of tools to use in terms of what you can write, what commands you can tell a computer to do, and with those you're going to be asked to solve problems in a repetitive manner. So if that's not what you thought this was, just letting you know now so you're not confused when we get there. It's not boring. Some people think it's really boring. It's actually a really kind of like mind-taxing thing. It takes kind of a logical mind in terms of thinking step to step to step to step. But it also involves a lot of creativity. There's a million ways you can solve the problems. That's why I said it's kind of up to you. Your code for some things might be this long, and someone else's might be this long, and they both, do the same thing. So, just letting you know that up front. So let's see here. So computer science, CS, we call it computer science. Is it really computer science? I don't think so. I think it's actually computational science, because we're not studying the computer. It's not a science of computers. We're not going to look at the hardware. We're not going to see what's in the computer and figure out how it works. We're not doing that. We're figuring out what problems can be computed and how to best compute them. Meaning, is something a repeatable thing? If it is, can we write an algorithm that will repeat it? And then, based on that, can we improve the algorithm to make it faster? So that's kind of what you do in computer science and CS. So I've always thought about it as computational science. So with that, here we've got this 111 class, which is an introduction to a foundation to programming, where, like I said, I'm going to give you the toolbox that will allow you to go on. If you read my lesson 0, I noted that we are using Python for the course, but that I'm not trying to make you a Python developer. I'm trying to teach you the basics of programming. It's much more important, especially because there's hundreds, thousands of languages out there. Each one better at a different thing. Think of those all as tools as well. And over your programming lifetime, you're going to need to pick up other languages. So if you fall in love with one, that's fine. That happens. But if you only know a language and its syntax and not the underlying ideas behind how it works, it's going to make it very difficult to learn new ones. So my goal here is to teach you the foundations of what go on in all programming, so that you can take what you learn here and apply it in other languages as well. If you go from this class, which is Python, to another class where you're maybe doing Java or C or C++, or maybe you're a web developer and you use .NET or something like that. Okay, so on the syllabus I posted, you'll see kind of a rundown of how this course is going to be laid out. For the first pretty much 8 weeks, we're going to be covering all the tools that you need to code. Followed up by 8 weeks after that of really, utilizing what we learned in the first 8 weeks to solve harder problems. So that's kind of the layout for the course. You have some leeway in terms of things that we can do. So if, in the middle of the semester or whenever you're thinking, hey, this would be a cool problem to solve, let me know. Maybe you see something online, or maybe you've always had an idea, or who knows what. We've had a lot of that happen in the past, and we've gotten some really cool things done with it. It's students have really creative minds, and a lot of the times, you come in here with some ideas that hey, I want to learn programming because I want to solve this, whatever that thing is. So let me know about that. I'd love to incorporate it into the class. I'd love to help you, achieve your goals in that regard. So I don't know if this is on the syllabus, but there's a big problem with cheating in computer science. What I mean by that is that you get an assignment and you just go and Google it and find someone else who wrote it and copy their code. So that's not acceptable. I assume you guys know that already. But I'm going to show you some ways that you can reference other people's code, because that is something that you do need to learn to do. You do need to learn to Google, hey, how do I solve this thing? And if someone's already done it and it works, then there's really not a point in you trying to do it better or different or something like that. If initially you want to look at it and gain the concepts out of it and write it in your own way, that's fine. But sometimes it just makes more sense to actually use their code. So I'll show you how to properly reference that so that I'm not saying you're stealing it. If you claim it for your own and it's not your own, that's stealing it. That's plagiarism. If you give the person that is the actual author credit for that, then we won't have any problems. So, all right. So the first kind of lesson I like to go over, I'll throw it in this video, is I guess kind of the idea of computers themselves, how they work a little bit, just so you can kind of understand where we're going with this. So within a computer you have a chip, the CPU, the Central Processing Unit, and most of them have one chip. It's really all you need to have, whether it's an Intel i7 or an AMD Athlon. It doesn't really matter what chip it is. They all generally work in the same manner. They have some different settings that allow them to be a little different, speedier, allow them to store more things in cache or whatever. If you don't know what that means, don't worry about it. But essentially, a CPU just processes instructions that are given to it. So what we are going to write are instructions that get sent to the CPU, and then it's going to enact them. So if I want it to show some text on the screen, I'm going to write some code that says, hey, show this on the screen. When it gets to the CPU and it's ran, the CPU is going to say, okay, the user wants this to be shown on screen, so I'm going to do that. So a lot of this class is about telling the computer what to do. I was once told that the computer's the dumbest thing you'll ever see. It only does exactly what you want it to do, which can be very frustrating if you write your code improperly, because it doesn't give you any hints and it doesn't help you out. It simply does what you tell it. And if you tell it to do something wrong, then it's going to do that wrong thing. Lucky for us, Python's a pretty safe language. You don't have to worry about deleting your hard drive or running out of RAM and your computer blowing up or anything like that. So that's a little about CPUs. The other thing is, for the most part, unless you have like a dual core, quad core, or something like that, CPUs only run one instruction set at a time. So what I mean is, maybe you're running Windows or Mac or Linux or whatever, right? And it's the background operating system. But your CPU physically, if you can think about it like a conveyor belt of instructions coming in, as they come in, and here's your CPU, it just only accepts like one at a time. And then when it's done with that, it's, grabs the next one. So that's how the CPU works. That's the longer things you write are going to run slower because it's only going to accept one instruction set at a time, one line at a time. It can only do one thing at a time. So even when you think about, oh, well, I'm running 15 programs at once, it just looks like it. Your computer's very, very, very fast. Think about gigahertz. I think it's like 1 trillion operations a second or something like that. So very, very, very quick. So it just is switching through the instructions so fast that you don't realize that it's only doing one thing at a time. So that's the intro here. That's kind of week 1. Next week we are going to get into setting up. So what I need you guys to do is I need you to send me an email and let me know if you're running Windows or Mac or Linux. That way I can kind of give instructions based on the majority of what people are doing in terms of how to get set up here and what we want to use for the course. Because you're going to have to download Python and you're going to have to run it on command line unless you use something like Aptana. But just let me know what operating system you're running, and then based on that I can make some specific videos targeting those things. Because by default I work on a Mac. Behind me you'll see I have a PC. So whatever we need to get for this course, we'll get. That, I believe, is all I've got. So shoot me an email, let me know that, and we'll get really into the nitty-gritty of programming here starting next week. Thanks.